Atoms are particularly small objects, and to get a look at them, we have to go beyond microscopy and into spectroscopy, which is revealing really what happens when you apply energy to a system. Photoelectron spectroscopy is a relatively obscure branch of spectroscopy. Most scientists are doing either NMR or infrared or something like that spectroscopy, but photoelectron is a really nice tool for a student, since it turns out that if you hit an atom with extremely high energy, for example X-ray, UV is sometimes used, it can remove not just the outermost shell of electrons, it can remove all the electrons, which is an astounding thing. And by doing so, it should reveal the Aufbau order, since the least energetic electrons will be the ones that will be removed first, etc. Here's the device, one that I've never seen, nor have I used. I believe there was one in the Westmoreland lab at Wesleyan University, which I attended, but I didn't really use it much. However, it gives rise to spectra that look like this. Now this is pretty ugly. It's pretty hard to tell what's going on. This apparently is a palladium spectra. But for most courses, notably advanced placement chemistry, they will idealize it for you, meaning clean it up quite a bit. And they're doing two things, and it's very nice and very much easier to deal with. Note that the energy has been switched around. You're going from low energy here to high energy here. And notice also that the number of electrons has been proportionalized nicely. That's 2 there, that's 6 there, for example. And that cleans it up quite a bit. The utility is that this device should reveal the Aufbau order, and interestingly, it does reveal some exceptions, which are curious in nature. Why do some elements seem to be exceptions to the Aufbau order? And there are certain patterns to it that should not surprise you. Which are the electrons that are hardest to rip off? Those would be the ones closest to the nucleus, where that power of attraction is the closest. For you're closest to a magnet, for example, it's the hardest to rip it off. So it's for the closest electrons from which nuclei? Well, it would be the nuclei with the highest positive charge. That would be the largest nuclei, you know, the ones with 118 protons, for example. This should be, I think, more or less common sense, but it is also expressed mathematically. This is Coulomb's law. Okay, typical questions are identifying elements, and it's not that bad. I think this is, let me think for a second, 2, 4, 10, 12, 13. I think this is aluminum. How do I know that? It follows the Aufbau order. 1s2, 2s2, 2p6, 3s2, and then it looks like only 3p1. That's aluminum. This is an introduction to photoelectron spectroscopy.